Hello, my name is Jachi Ojiako, and this is my presentation for Elec 3665 Embedded Systems for the calculator project, microcontroller project. And yeah, so this is my setup. I'm gonna just turn on the board. So you see, as we turn on the board, we get the screen lights up and everything. So yeah, sorry for the messy wires. I literally just traveled traveled back from Scotland. Packing the calculator was kind of hard, so the wires got messed up in the process, but it shouldn't really affect the functionality. So I mean, the first function that we have on the the first function we have is LCD and keypad functionality. So you can see that as I press keys on the keypad, you can see that the corresponding keys appear on the LCD, and we know that hash is for delete, so I can delete these keys like so. And yeah, so basically, and we also have functionality for when the numbers go out of the screen, we can still, so we have 889, and I can still delete that. And yeah, so we still have functionality for when numbers go out of the screen, and then obviously star is to calculate. So that's that so far. And my second feature for this project is floating point calculations. So basically, we know C is the decimal point. So 45, let's say 45.5 minus 20, and you'll see that we get 25.5 as the answer. And actually, if we use very large numbers or very low small numbers, we actually automatically convert to scientific notation, and that's part of the code. That's from the code that's written on the calculator. So for example, if I use 12, and then shift C for E, right? So 12 5, let's say, times 49. See my answer in scientific notation, 5.88, and then we get E plus 0.7, so 5 raised to the power 5.88 times 10 raised to the power 7, basically. So yeah, that's just the floating point calculations with scientific notation. And then the PEMDAS functionality, so this allows for nested calculations. So when we have multiple operators, 1 plus 859, let's say, divided by 4 8s minus 5, let's say, plus, or sorry, I just delete that. That was a mistake, sorry. So let's just say 45 times 89 minus 65 plus 2, or 3.4. So we can see this has multiple operators, but we're using PEMDAS, and we should be able to solve it and get the answer. Yeah. So this is my PEMDAS functionality that demonstrates that. And then the last thing we have is positive and negative resolution. So what this really deals with is, for example, if I type in 4 plus minus 5. We know, like, just from normal math, you can do this in your head. You get 4 plus minus 5, which is 4 minus 5, so you should get minus 1. But the calculator is actually able to resolve this itself, so if we press enter, we get minus 1. So that's the positive and negative resolution. Is able to kind of go through each sign, and it's able to resolve that into one sign, which is then used in the calculation. So that's the positive negative resolution that's implemented on my calculator. So yeah, thank you. I mean, this took a lot of work. I hope you see my originality, my creativeness, and yeah, it was hard work. So thank you for the project. It really opened me up to a lot of new things. I learned a lot, and I feel like I hope I did a good job. So yeah.